Okay, children, now let us do the example problems of modular arithmetic. Example 2.11. Find the remainder when 7 lakhs and 4 and 778 is divisible by 7. Not 7 lakh, 70,004. Okay, 1, 10, 100,000, 10,000. So 70,004 and 778 is divided by 7. So you have to use congruent modulo to find the reminders for these numbers when it is divided by 7. It's one easy method. Here it is 1 7, the remaining numbers are 0 0 0, isn't it? 70,004. So you simply take 70,000. We know that 70,000 is divisible by 7, isn't it? So you get 10,000 when you are dividing. So since 70,000 is divisible by 7, we can write like this: 70,000 is congruent to 0, remainder 0 mod 7. Now here on 4 is there. We know that theorem 6 says that you can add or subtract or multiply any constant integer, isn't it? Any integer constant. So you can add 4 on both sides. So what do you get? 70,000 plus 4 is equal to 0 plus 4 mod 7. So 70,004 is congruent to 4 mod 7. That is the answer for the first one. The remainder is 4. Then the next question, 778 is divisible by 7. So what it is? Nearest value, you take 3 sevens. 777 is divisible by 7. So we know that 777 is congruent to 0 mod 7. You have to add 1 on both sides. So you get the remainder is 1. Okay, children. So 70,004 you get the remainder 4, and 778 you get the remainder 1. Then next problem. Determine example 2.12. Determine the value of d such that 15 congruent to 3 mod d. Determine the value of d. The divisor you have to find out. When you take this 3 on left hand side, so what do you get? 15 minus 3 is a multiple of d or divisible by d. So we can write it as 15 minus 3 is equal to some k into d, where k is some integer. Then 15 minus 3 is equal to 12. So you get 12 is equal to k into d. We have to find out the value of d, isn't it? So d is equal to 12 by k. So what are the divisors of this 12? The k, when you are putting 1, it is divisible by 12 is divisible by 1, and k is 2, k is 3, k is 4, then 5 is not, then 6 and 12. So 1, 2, 3, 4, 6 and 12. But the remainder, the divisor is always greater than the remainder. See that here, what is the remainder given? 3 is the remainder, isn't it? So the divisors should be, d is the divisor. D is the divisor. So divisor is always greater than the remainder. That is, remainder is 3. So what are the numbers greater than 3? 4, 6 and 12. That is the answer. Divisor should be larger than 3. So the possible values are 4, 6 and 12. The next example, 2.13. Find the least positive value of x such that the two questions will be there. You have to find out only least positive value. We no need all the values, only least positive value only we have to find out. Take the first question. 67 plus x congruent to 1 mod 4. Take this 1 on left hand side. So 67 plus x minus 1 is a multiple of 4 or divisible by 4. So 67 minus 1, that is 66, plus x is a multiple of 4. So we can find the least value that you have to add with 66 so that it become a multiple of 4. Here it is plus x, isn't it? So you want to find out what number should be added with 66. So it is divisible by 4. We can just divide this 66 by 4. So you get the remainder is 2, isn't it? Remainder 2 means the divisor minus the remainder. Again 2 you get. So when you are adding 66 plus 2, you get 68. 68 is a multiple of 4. So the least positive value. If the remainder is 4, it is completely divisible by 4, isn't it? So we have to add 2 with this remainder. So that 2 should be added with the dividend. So 66 plus 2, that is 66 plus 2, that is 68, is multiple of 4. So the least positive value of x is 2. That is the answer for the given question. The second one, 66 plus 2 equal to 66. 68 is the nearest multiple of 4 more than 66. The next question, 98 congruent to x plus 4 mod 5. You take this on left hand side. So minus x plus 4 is a multiple of 5. Then remove the bracket. So you get 98 minus x minus 4 is a multiple of 5. Then 98 minus 4, you get 94 minus x is a multiple of 5. Here it is minus x. So what number you have to subtract so that this number become a multiple of 5? The nearest value is 90, isn't it? 90 is a multiple of 5. So that means you have to subtract 4 from this number. 94 minus 4, you get 90. You simply, if you want, you can divide like this. The remainder is 4. So 4 only you want to subtract from 94 so that it become 90. So the least positive value of x is 4. So 94 minus 4 is 90, is the nearest multiple of 5 less than 94. The next example, 2.14. Solve 8x congruent to 1 mod 11. Solve means you have to find out the value of x. Take this 1 on left hand side. 8x minus 1 is a multiple of 11. Then multiple of 11 means you can write it as 8x minus 1 is equal to 11 into k. So for some integer k. So 8x equal to 11k. Take this minus 1 on right side. So 11k plus 1. Our aim is you have to find out the value of x. So 11k plus 1 by 8. Then when you subtract any number for k, it should be divisible by 8. When your k is equal to 1 means 11 plus 1, 12. 12 is not completely divisible by 8, isn't it? Then 2 means 22 plus 1, 23. It is also not divisible. Then 3 means 33 plus 1, 34. Not divisible. 4 means 44 plus 1, 45. Not divisible. Then 5 means 55 plus 1, 56. Then 7 8s are 56. So we have to substitute 5, isn't it? K is equal to 5. K is, when you are putting K is equal to 5, X equal to 55 plus 1, 56 by 8, you get 7. So the least value we can find out, but this equation having so many values, so you have to add like this. The next solution is, first least value 7, the next value you have to add the divisor 11 with this number. So 7 plus 11. The next number, how will you find out? 7 plus 2 times you have to add the divisor, 2 into 11. So you get 7 here. 7 plus 11, you get 18. 2 into 11, 22. 22 plus 7, 29. Like that the numbers will be coming. So you have to write the solution like this, okay? Then compute X such that 10 power 4 is congruent to X mod 19. That is, we know that 10 square is equal to 100. When you are dividing 100 by 19, you get the remainder is 5. So 100 is congruent to 5 mod 19. So we can write it as 10 square is congruent to 5 mod 19. Now you take square on both sides. So 10 square, the whole square, is congruent to 5 square mod 19. So what do you get? 10 power 4 is equal to, congruent to 5 square is 25 mod 19. The remainder is always less than the divisor, isn't it? So you have to divide 25 by 19. So remainder you get 6. So 10 power 4 congruent to 6 mod 19. So the value of X is 6 here. That is the answer for the given question. Then 2.16. Find the number of integer solution of 3x congruent to 1 mod 15. So take 1 on left hand side. 3x minus 1 is a multiple of 15. So we can write it as it is 15k for some integer k. You have to find out the integer solution. So find the x. 3x is equal to 15k plus 1. X equal to 15k plus 1 by 3. Divide it separately. So what do you get? 15k by 3 plus 1 by 3. Here we can get cancel and you get 5k. 5 3s are 15. Here it is 1 by 3. Integer solution x is having two parts. One is integer and one rational part is also there. So totally it is not an integer. So here 5k is integer. 5k plus 1 by 3 is not an integer. Therefore no integer solution for the given question. Next question is 2.17. A man starts his journey from Chennai to Delhi by train. He starts at 22:30 hours on Wednesday. If it takes 32 hours of traveling time and assuming that the train is not late, when will he reach Delhi? Train is not late. Train late illa. Chennai to Delhi. His journey is from Chennai to Delhi. Starting time 22:30. That means it is midnight on Wednesday. He take 32 hours of traveling time. So when he reach that Delhi. Okay children. Starting time you have to write 22:30 hours on Wednesday. Traveling time 32 hours. So when will he reach that reaching time? So you have to add these two. 22:30 plus 32. So you get 54:30. Then you have to find out when he reached Delhi. So 54:30 he reached Delhi. That means you have to find out 24 hours means it is 1 day, isn't it? So you have to divide the number by 24 with mod 24. So while you are dividing, you get the remainder is 630. So when he reached Delhi at 6:30, but which day? His starting time is on Wednesday, isn't it? But 6:30 in which day? How will you find that day? The 32 hours traveling time. That traveling time also you have to divide it by 24. So by Euclid's division lemma, we can write like this: 32 divided by 24 means you get the remainder 8. So 32 can be written as 24 into 1 plus 8. 24 hours means it is one day. He start on Wednesday, isn't it? Now he is starting on Wednesday means this one is Thursday. 24 into 1, that is Thursday. And 8 is on Friday. So he will reach Delhi on Friday 6:30 hours. The next problem 2.18. Kala and Vani are friends. Kala says today is my birthday, and she asks Vani, when will you celebrate your birthday? Vani replies, today is Monday and I celebrated my birthday 75 days ago. Find the day when Vani celebrated her birthday. Do you understand, children? Kala and Vani are two friends. Kala says today is my birthday, but Vani, she asks Vani, when will you celebrate your birthday? So Vani replies, today is Monday and I celebrate my birthday 75 days ago. So you have to find out the day, what day she is celebrated. So we take 0 for Sunday. We can numeric value only we have to use for doing calculations. So we can assume that 0 is Sunday, 1 Monday, 2 Tuesday, 3 Wednesday and 4 Thursday, 5 Friday and 6 Saturday. Vani says today is Monday. So the numerical value is 1. Then her birthday is 75 days ago. That means from this 1 you have to subtract 75. And the day will be rotated, wrapping around for 7 days, isn't it? Totally. So mod 7. It is congruent to minus 74 mod 7. When you are dividing this 74 by 7, you get the remainder as 4. Since it is minus, you get minus 4. But remainder is not minus. So what to do? You have to subtract the remainder from the divisor. So you get 7 minus 4. 7 minus 4 means you get 3. What this 3 shows? 3 is on Wednesday. 3 shows it is Wednesday. Therefore, Vani's birthday must be on Wednesday. That is the answer for the given question. Thank you, children. Study well. Day-to-day portion, you have to study well.